Okay, today, this is 2.1 day 2, and we're taking functions up to the next level. So first of all, you just stick in a 4 in the f function. This is no big deal. Put a 4 in here, and I find out f of 4 is 2 times, here, you know what I should have done? Let me show you. I want to have a consistent process for this. I write 2 empty spot squared minus 1. I call it the skeleton form of this equation. Now I'm going to drop in what? It said 4. So I put a 4. So that's 16 times the 2, 32 minus 1, 31. Raise your hand if you had 31. Okay. If that was not easy for you, I'm scared for you and what's coming next. All right. So f of x is 5. That's different because I didn't tell you x. I told you y. Think about it. F of x is the same thing as y, right? So do you get, I did not say what the x is. I said that the y was 5. Well, where's f of x in this? Oh, it's right there. What did I just say that the f of x was? 5. So I put a 5 in there. Now solve it. And be careful when you get to your x squared thing, because you remember how when you take the square root of that, something magical happens? It's not just a plus and a minus thing. You need to have learned that by now. Three equals x squared. At this moment, it's a big moment because you either revert back to what you learned a long time ago, which I understand got stuck in your head pretty heavily, but hopefully you've gotten smart enough to know it's absolute value x equals square root of 3. Have you caught that yet? How many of you put that on your paper? Okay, some of you still aren't catching on, then that's going to hurt you on the test. All right, so the square root of x squared is absolute value x. I proved it, I graphed it for you, all kinds of good stuff. Now I'm going to break it into two parts. X equals plus the square root of 3, and x equals the opposite of the square root of 3. And I know some of you just tried to shortcut that, but then you don't really understand, and that's going to catch you. All right, root 3, negative root 3. Do you get that they wanted what x was? It says x equals what? Now we know what x equals. All right, next kind. You have to get used to whatever they put right here, that's supposed to be x, f of x, right? So aren't they saying that you should put in for x, put in c plus 1, where the x was? Yeah, that's all they're saying. F of c plus 1 means put this in for the x. Okay, so let's do that. Skeleton form. Drop in c plus 1. Can I just leave it that way? No, you have to actually multiply it all the way out. And you have to do it in the right order and everything. Go ahead and do that. And let's see what you get. And the next thing, you have no clue what that is, but you're going to be using it in calculus. It's a really big deal function in calculus. And we here in pre-calc, we're going to teach you how to stick in x plus h into a function. All right, I hope you were smart enough to know it's not just c squared and 1 squared. Did you remember that? It's 2 times c plus 1 times c plus 1. And then you subtract 1. And so this becomes c squared plus 2c plus 1. And then I have to times all of that by 2. So 2c squared plus, it was 2c already because there's 1c and 1c makes 2c. And then you got to double it, makes 4c plus, and 1 times 1 would have made 1, but we got to double it, so 2. And then there's a minus 1 at the very end, so minus 1. And 2 minus 1, of course, is just 1. And so there is your final answer. 2c squared plus 4c plus 1. Raise your hand if you had that one right. Good. If you're getting all these right, it means you're good at algebra. And algebra is a big deal in this class. Honestly, pre-calc isn't, the concepts in pre-calc aren't that hard. It's the algebra, grinding out the algebra that's so important. And that's why I put my kids last year through the torture of the top 20. Because if you have all those 20 things down, then this class won't be that bad. So that's why I started this class with the top 20. And some of you aren't good at that. That's why you got 3 out of 20. I saw. And so you just need to fix it now. Get good at that. If you get good at the algebra this class, lots of A's. Usually, because I push people pretty hard to get through that top 20, the people that play along and actually learn all those things on the top 20 end up getting A's in this class. I get tons of A's all the way through the whole first semester. And then second semester happens. It's not that bad. But second semester is where the trig is, and your algebra can't save you then. All right. So I'm going to put x plus h into that f function. So what do? I start with the skeleton of the function. I drop in 2 empty spot squared minus 1. And then I'm supposed to put in x plus h, so I do. X plus h. And then it's got this minus f of x thing happening. Minus f of x. I'm going to write an entire empty parenthesis and then drop in what f of x is. F of x is that. Now, why didn't I just slap a negative on the front of this and say negative 2x squared minus 1? Because then I would have been forgetting to distribute the negative. That's why I put that f of x in a parenthesis, and that's what I strongly recommend you do. You're going to have to do this. This is something we make you do, not just on homework. So when you see the f of x, put it in parentheses, because the really common mistake is to forget to distribute the negative. All right, this gets icky. I've already helped you by reminding you about the parentheses, or a lot of people would have goofed that up. Would you please take it from here all the way to the end, and some things happen. Like some stuff cancels out, and you get an answer that's just like, you know, x plus h, or 2x plus h. So multiply this all the way out and clean it up after everything cancels and the smoke all clears. Your answer should, I'm not saying what it is, but it'll be something like 2x plus 3h or something like that. So multiply this all the way out and clean it up. That is a typical thing that we do to functions in pre-calc. Okay, so I'm going to do it really fast. X plus h, x plus h. And now I'm going to multiply out another step. I'm going to get this part done because it was originally a power, and powers are supposed to come before multiply by 2, right? So I'm going to wait for the multiply by 2 until later. X squared plus xh plus another xh makes 2xh plus hh is h squared. And then I got a minus 1. But the minus 1 and the plus 1, look at that. Minus 1 and plus 1, they're just going to cancel each other out. So that's gone. Yay. So then I just have minus 2x squared. Now, I'm going to multiply this out again. 2x squared, this times this times that, plus 4xh, and that times that, plus 2h squared, minus 2x squared, and something else cancels. Did you see the 2x squared and the negative 2x squared and how they will cancel each other? Final answer, 4xh plus 2h squared. How many were you able to fight through all that algebra and get that? Okay, good. That's another topic mastered for our next test. All right. So, this next part freaks people out, and I want to remind you, what's your best friend in graphing? I mentioned this before. You can graph anything with this technique. Yes? XY chart. I'm telling you, a lot of kids just still want to be like, well, I want to know what it looks like, and I just want to move it around. You don't know what it looks like a lot of times. And your best friend in graphing is the XY chart. So we are going to follow these little like steps over here and try to graph these things so that we can find the domain and range of them. All right, y equals x minus a, where x is greater than 0 and a is greater than 0. All right, it says let a equal an easy value. Remember, if it says a is greater than 0, couldn't a be like 1? All right, so let's make a be 1. But one bad thing about 1 is 1 has some weird properties. Do you get if you multiply something by 1, you didn't even change it? Do you get to take 1 and you put it like to the 3rd power, it's still 1? 1 has weird properties. This is a good tip for the ACT also. when offered the option to pick a number, don't pick 1, because 0 is also a bad choice. This one says bigger than 0, so you wouldn't pick 0. 0 is also a bad choice because 0 does weird things to numbers. But 1 has weird properties that most other numbers don't. So don't ever pick 0 or 1. So let's pick it to be 2. I think let a equal 2 is a great idea. All right, so if a is 2, then do you get, this is really just y equals x minus 2. Okay. Well, I hope you know what y equals x minus 2 is. And if you don't, you could always do this. Find some points. Put in 0, get negative 2. Put in 1, get negative 1. Put in 2, get 0. And you could just graph some points. But I hope you recognize y equals x minus 2 is like a super simple graph from a long time ago. It goes through negative 2 and has a slope of 1. There's what my graph generally looks like. Now, would you agree I capriciously chose a to be 2? Do you get I could have picked a to be 17 if I wanted to? All right. Now, do you get, if I had chose a to be like 3, do you get this would be a 3 and then the line would be down here? So these aren't just a normal function. This is a family of functions where it could have looked like this. It could have looked like that. It could have looked like this. Do you get it couldn't have looked like this red one? Because I wasn't allowed to pick a equal to 0. See what I mean? So this is a family of functions that would go through there, but wouldn't ever be this high. It would have to stay underneath that. So I could make one more blue one and kind of sandwich it in there, but do you get that that's a family of functions? All right, next, it says it wants x to be greater than or equal to 0. That means I can't even have x equal to 0, right? Do you get on my graph then that that's where x equals 0, so they have to stay on that side of the line right there? So these are kind of weird. It's like a function, except you can't just graph here's where it is. Where it is depends on what you pick for x and a. All right, I sketched the function. Now it says look for intercepts and vertices. Remind you of a statement I made the other day. The x-intercept is where what? Y equals 0. The y-intercept is where what? X equals 0. Do you get that it didn't let me let x equal 0? But if it had, do you get if x had been 0, then that would have been a 0, and y would have just equaled negative a, and whatever you picked for a. And again, we picked an easy thing like 2 just to like have an idea. Y would have been negative 2. So that means I've got a y-intercept of whatever you pick. See how these are the y-intercepts? They're whatever you pick right here. But technically, the y-intercept can't exist because x has to be greater than 0. All right. Now what else can we examine? Put a back in and then adjust the intercepts and the vertices. That's this part where I was saying, but you picked a to be 2. But a could have been anything. And all of a sudden, if I had put in like 7, this would be y equals x minus 7, and it would be like down here. So your final answer is these are a family of functions. Let's do another one. These bother people every year. But if you just follow these little steps, and you say x has to be bigger than a half, or 1/2 a, sorry. So you have to do it that way. And you have to say a is bigger than 0. Pick anything you want for a, but what was my tip? Don't use what? 1. So let's pick 2. Let's let a be 2. Then a is 2. Then y equals 4x minus 2x squared. And now I have to graph that. Do you have any clue what that even looks like? So then what's your best friend in graphing? XY chart. Can't use a calculator on these tests. All right. I feel like we've gone too fast. I want to give you another one. Let's say I said y equals x squared, except it's going to be minus a. I want you to picture, where is y equals x squared? Would you make a sketch of that? Because I know you know what it looks like. Now, if I didn't put any limits on a, if I didn't say anything about a, then this function could be anywhere, right? Do you get how a would be the y-intercept? Because if you set x equal to 0, it'll just be a. I still feel like I'm maybe going too fast. Okay, so what was the first little step in our steps? It was let a be simple. And I said 2 is a good simple number. So let's let it be 2. So y equals x squared minus 2. Do you get it? Then it would be down here. Okay. Then if I can let a be anything I want, do you get that that means if it could be anything, then this could go further down? Or even if you put in negative numbers like negative 6, you'd have x squared plus 6, and it'd be up here. So this is the family of functions. And I could go like this. It could be up here, or it could be down here. And it's a family of a whole bunch of parabolas. But that isn't typically how it is. Typically, they say, oh, a has to be bigger than 0. Then you got to narrow it down. Would you please make this one be a family of functions if y equals x squared minus a and a has to be greater than 0. Would you draw the family of functions in the right spot, please? That is not one of the right answers, because a has to be bigger than 0. In this case, a would be 0. Draw the little family of functions that goes with this. I'm going to pause for a second. This is, if you can't get this one, we shouldn't move on to those tricky ones yet. Pause for a second. Okay. So did you get that if you started with 2, that this would be a 2, and then the whole thing shifted down a couple, and so the first one you would have is not the blue one, it would be actually the black one. Okay? Then, depending on what you make A, B, it'd be a whole family of these things. And the lowest one would get really close to 0, but has to be a tiny bit below, or yeah, a tiny bit below 0. You get what I'm saying? Okay. All right. So now, what's the domain and range of that? If you just look at those, do you get that they're parabolas and therefore they go forever left and right? So the domain of it would be from negative infinity, positive infinity. What's the shortcut I just told you today? Big R with the double straight line to make the big R. All real numbers. The domain is all reals. But because A has to be bigger than 0, and then when you actually put it in practice, there's a minus in here. And that means if I pick a number like 2, you can see the thing's going to get shifted down by some amount. Do you get that this range of this thing, it always goes up forever. So the top end of my range is infinity. Do you get that? That it'll always go up as far as it wants to. It'll keep going up. But how low it goes is up to you and what you pick for A. And what's the highest range that you could possibly, like that number, do you get, it could go from here and go lower, 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 and you get to pick what A is, and therefore it could go lower and lower and lower, and that there is no limit on how low it could go? Because you get to pick the A? So does the range depend on what A you pick? If you pick A was like 6, do you get that it would be this one? And then I'd have a range that would be from -6 to infinity. So it does depend on what you pick for A, doesn't it? So -A to infinity. All right. Donner's pre-calc. It's not supposed to be super easy. Hey, you have the test tomorrow? No, you don't have to understand it yet. All right. Your homework for tonight. This is one of them, but we already did those. Yay. So we have already seen a lot of the homework for this, and I had you skip a bunch of them. All I want you to do for tonight is, hold on just a second, I'm going to pause and find it. Here's the file that I was posted for tonight's homework. It's called Homework 2.1 Day 2. And I want you to graph a couple of these. Remember how they look kind of crazy. It's not just like, oh, here's my graph. It's you start with something like that, and then you figure out where it goes. Like, I guess mine is going to go lower and lower and lower and lower and lower. And so then you can see them as a family of functions. Okay? All right, so I want you to do these two on the first page. This is another good one. Do you remember what the square root function looks like? Looks kind of like that. And if you had to, you could always make an XY chart to remember what the square root of x looks like. All right, so I want you to do that one. I want you to skip this one. On this, it's just sticking numbers into functions. You don't need that much practice on it. So I'm fine with us just doing the top one by the birds here. Just do that one and skip the rest of them on the page. And this is asking you to find the x and the y intercepts. It's great practice. You don't need to do that many, though. You know why it's telling you to do the x and the y intercepts? Because it's saying y is 0, and then you get the x-intercept. And it's saying x is 0 by saying that. So this is just a fancy way to say find the x and the y-intercepts. I think you should do that for just the top one. Find the x and y-intercepts on that. One more, and 30. And then that's it. Done with the homework. No more homework after that. Okay? Do the ones I assigned. Get them done. Haven't gotten anything in the grade book in the last couple days, so I'd love to get some in the grade book. Oh, and I just remembered. This is an assignment, but it's not due tomorrow. As in, this is stuff that you should work on, but I can't make it due tomorrow because this is that one of those times when it's a special holiday, and so it's a holiday from homework for you too. So you don't have to do it tonight. Eventually, at some point, you got to have this done. But I'm going to give you several days over which you can get it done. All right, so now I got some time to work in class. And if you're super bright, you're going to get done with a lot of this in class. Okay, question quick? A little louder. Let's talk about that off the video. All right, done with that. That's all I got for today.